My name is Chloe, and I am a Makerspace Coordinator here at Pacific Science Center. Welcome to Amateur Radio on the International Space Station, or ARIS for short. ARIS is a program using resources from the International Space Station, U.S. National Laboratory that promotes the exploration of STEM topics by granting educational organizations, such as a science center, a scheduled contact with the astronauts currently on the ISS using amateur radio. We at PacSci applied for one of those contacts in February and were selected, allowing us to host this event today. For the last 6 months, we have been working hard to order, assemble, and test all of the equipment that we will be using, including the ICOM 9700, for this contact. We have also been delivering curriculum and workshops with the Discovery Corps youth who will be interviewing the ISS crew member, Jeanette Epps, today. Discovery Corps is a group of teens supported as PacSci staff members that work with many departments around the Science Center by serving guests, conducting research, and participating in unique STEM and education-related enrichment activities. These teens have been learning about how the ionosphere influences radio propagation, how solar events and space weather influences satellites, as well as interview and public speaking etiquette, to name a few of their lessons. They also successfully built a Yagi tape measure antenna, soldered an attenuator kit, and conducted a fox hunt around Seattle Center. At this point, many of you might be wondering what amateur radio is and how we will be using it today. Lucky for you, we will have a couple of presentations introducing that exact topic. To start, we will hear from Dr. Susanna Cunningham and Tim Helming from Seattle Auxiliary Communication Services. Seattle ACS is an emergency communications team of trained volunteers serving Seattle. These volunteers are licensed amateur radio operators and registered state emergency workers. Susanna and Tim will discuss their work with the team and introduce you all to just one possibility of amateur radio, emergency communications. The next presentation will be led by Eric Linksweiler, a member of West Seattle Amateur Radio Club, who will discuss current events on the ISS, barriers that have or could have impacted this contact today, as well as his work with Scouts and the Radio Merit Badge. This presentation will highlight how special this contact is given the many responsibilities of the crew member we will be speaking to. Eric has been our main point of contact throughout the last 6 months, and we are extremely grateful for his time and expertise. All right, Tim and Susanna, ready?
Well, good morning. We're happy to be here with you. So we're going to start, next slide, please, by introducing ourselves. And we are going to talk about, as you know, amateur radio and emergency communications. So we'll let the director of the Auxiliary Communication Service start out by telling us a bit about himself.
All right, Susanna, thank you. Well, to be part of a volunteer organization that does all the things that we do involves quite a bit of passion. And for me, that passion started really young. I was one of those little kids that used to turn on the AM radio at night, usually in my room under the covers so I wouldn't get busted by my parents, and see how distant a station I could pull in with that radio. And sometimes it would be several states away. And as our young folks have learned about ionospheric effects of propagation, it would vary from one day to the other. And so radio was magic to me from the very beginning. And even though now I know a few technical things about kind of how it works, it's still magic to me. And when I realized that I could take this excitement and passion that I had for this thing called radio and give back to my community through volunteering for emergency communications, that was too good a deal to pass up. So I've been doing that for 30 years or so, give or take. Susanna.
Well, I got in it for the opposite reason, utility. And I am by background, a nurse scientist, and I believe in preventing things. And so when I learned that there were things known as emergency communication hubs in neighborhoods in Seattle, I got involved, and then I discovered that amateur radio was involved. And I'd had a license years ago, and I reactivated it because I really want to help our community be ready when the earthquake, which is the worst disaster we're probably facing, comes. So for me, it's more about making things happen for my community. So
Awesome.
next slide, please. So how many in this audience are not amateur radio operators? Great. And how many are amateur radio operators?
That
Look at-
first group is future amateur radio operators.
That's all. We're always recruiting. So come and join us. Everyone can be an amateur radio operator. So I'm going to tell you a few things about amateur radio. I could probably talk for days about it, but we don't want that. So it's a worldwide hobby. It's non-commercial two-way radio. So it's a way for us to communicate with people near and far. We can do it locally, as close as here to here, and far to anywhere around the world. Every country in the world except for North Korea and Yemen has amateur radio operators. On the International Space Station, 7 out of the 9 cosmonauts and astronauts that are there right now are amateur radio operators. Jeanette Epps, who you're going to be hearing about, actually has something that all of us amateur radio operators have, which is a call sign. We are identified by a number we get from the Federal Communication or number and letters from the FCC, Federal Communication Commission. So Jeanette Epps, who you'll be hearing, is KF5QNU. I'm WB7CON.
I'm WT1IM.
So to be radio operators, we have to pass an exam and get a license. And it's very simple. You can have very simple equipment, or you could have things that look like this. All right, next slide, please. All right, so Tim and I are members of the Seattle Amateur Radio, as well as Seattle Amateur Radio, but the Auxiliary Communication Service. Do you want to talk about the mission?
Sure. So our mission, Seattle ACS, is run under the auspices of Seattle Office of Emergency Management. And our charter is to provide emergency communications at the direction of the Office of Emergency Management in emergency conditions, or even in more routine conditions where extra communications support is needed. So we have folks that will, when they ask us to activate, we will operate out of the Emergency Operations Center, which is near Pioneer Square or the ID. And we have folks out in the field across the city. And our job is to provide whatever kind of communications the city needs to have situational awareness, to understand what's going on the ground, to be able to relay messages out to the folks in the city, and through our partners with the hubs right down into the neighborhoods. Because during a big event, commercial communications may be disrupted, they may be overloaded, they may be unavailable. And it's not just disasters. When the Seahawks managed to win the Super Bowl and they had that great big victory parade, that was a pretty good thing. And cell communications near the parade route were absolutely overloaded, barely worked at all. So there are all kinds of conditions that could cause us to need to provide this auxiliary support. Let's have our next slide. So our volunteers are, as Susanna said, there are some qualifications. You have to have an amateur radio license. You have to pass some self-study courses that are from FEMA on the incident command system, which is a administrative structure that we work under when we are deployed on an event. And it's something that we practice in our own drills as well. But any adult can be part of Seattle ACS if you pass those qualifications. And I would love to see some of the people in the room who raised their hands initially say they're not amateur radio operators consider volunteering in this way. And I think what you're going to see today, especially when the folks are talking to the astronauts, it's pretty exciting to get on the radio, and it's a really fun hobby. So great way to contribute back to the community. We've got about 150 volunteers in Seattle ACS right now. Have the next one. So what it is that we do, I think I've described that to some extent, but the picture up there is of a drill that we carried out with our partners, the Seattle Emergency Hubs. And we were simulating the kinds of messages that would go back and forth between the city at the EOC and the folks out in the field in the aftermath of a big earthquake, or in the aftermath of an extended power failure, something like that. And so we take this equipment out into the field. I've got a little bit of show and tell here. You can come talk to me later on if there's time after the whole event, but there's a radio in here, which is kind of what you'd expect. Here's a microphone. I can talk to people with it, but I've also got a laptop an important part of what we do is facilitating data communications. With what's in this box, without any commercial power and without any commercial internet or anything like that, I can flip some switches, get into some software, and I can send and receive email from this with no connection to Wi-Fi, anything like that, all over amateur radio spectrum. That turns out to be pretty helpful when you're trying to relay messages around a city. And we've got some other digital modes that we can do as well for sending those kinds of messages. So we tend to think of ham radio as talking on a microphone. Not always. It can involve data communication. In fact, this thing, when I take it outside, this is entirely self-contained. I can connect to a system that we have around here called HamWAN and Wide Area Network. This allows me to have multi-megabit connection entirely outside of commercial ISPs. And that's really good for being able to send messages around very quickly. So all I have to do is open up this box, plug in the battery, point it toward one of our HamWAN sites, and away we go. So you don't necessarily think of something like this when you think of amateur radio, and yet it is an important tool in the box. Next slide. We have a lot of folks that are very skilled technically. We have infrastructure around the city, on city facilities and sometimes non-city facilities, but that allows us to communicate back and forth. When we use our little handheld radios, they don't go very far, but when we can send that signal through a repeater, which is some of the infrastructure that we maintain, then that signal from that little handheld radio can get across the city. So that's very helpful. So we have a lot of technical infrastructure. Some of the folks on our team don't talk on the radio very often, but they're instrumental in supporting all the infrastructure that those of us who are talking on the radio rely on. All volunteer done, donation supported, et cetera. Let's have the next one. So if you find the concept of emergency communication interesting from a career perspective, there are ways that you can, different ways that you can get into this. So the background picture there was, those are the folks, that background picture is from the Office of Emergency Management, the Emergency Operations Center. And that was an activation. That was actually an example of a, not really emergency activation, but a preparedness activation when we had the Major League Baseball All-Star game here in town. You were always concerned about security events or anything like that. So the EOC was activated. Fortunately, nothing bad happened. And we just got to watch baseball on a really big screen in there. But the people populating that room are professionals involved in emergency management, planning, logistics, coordination, working with the other city agencies to make sure everybody has what they need. ACS works very closely with the fire department, by the way. That's one of the agencies that we provide backup communications for. There was a photo of a woman up there who is a dispatcher. So if you like the idea of talking on the radio and getting paid for it, well, consider getting a career in being a dispatcher for a fire department or a police department or something like that. Or heck, be an air traffic controller. There are lots of ways that you can parlay your interest in radio into a rewarding career. And then if you mostly like the technical aspects of things, well, again, there's a lot of need for technical infrastructure to support routine as well as emergency communication. So there's so many ways that we can get that you can get involved in this, either as a volunteer or as part of your career. So I think we are pretty much out of time. Thank you so much. And if time permits, at the end of the whole thing, if you want to talk to us, please feel free to. But great to see everybody here. And we are super excited about the astronaut contact later on. Thanks.
T-minus 22 minutes and 37 seconds.
Hi, I'm Eric Linksweiler. My call sign, because we're all giving us W7FCL. I've been a ham for a long time. My grandfather was a ham. My dad was a ham. They wanted me to learn Morse code. I hated Morse code. I would never learn it. If I saw one more audio tape cassette of Morse code, I'd probably throw up. But they let hams not have to learn Morse code in the mid-90s. So it gave me an opportunity to actually get started with learning a little bit about this. So if you could put this on a slide. Excellent. I really want you to focus on the slide. So I'm going to step back so we can talk about what I'm going to show you here. This is really special. It's really amateur radio on the ISS. You see a symbol for radio, which shows an antenna, a coil, and then the ground. You'll see that a lot with people that do amateur radio. And then, of course, the logo for the ISS. Next. Radio started in space, oddly enough, not too long ago. So the first astronaut to carry it on board was on the space shuttle. This is Owen Garriott, and he carried it on the Space Lab. This is not Skylab. He tried to get amateur radio on Skylab, but they wouldn't let him have it because it wasn't purpose built for that. So the space station, they brought up a handheld and he could try this. That's his picture doing it from there. And that launched a program called SAREX, which is Shuttle Amateur Radio Experiment. That was my first time talking about space. I was a student at Ohio State University and we had this kind of setup that we have today. And we were able to actually talk on it. It was really cool and a fun way to prove that you were a geek. Next. Actually, when I was, after this first pass, this is my rejection letter from NASA. I applied to be an astronaut when I was 12. My sister, when she saw this, said, that's firstborn syndrome for you. So this is my favorite rejection letter I ever received. So this was just because there was so much interest in space. And that led me then getting more interested in radio because I knew that that was some way I could connect to NASA. Next. So in 1984, they started designing what was going to be on the ISS. So one of those lessons was amateur radio. The 15 different countries were involved in running this or building it. 5 countries are currently focused on operating it. Of course, the US, the Russians, the European Space Agency, and the Japanese Space Agency, and I can never remember the 5th. So maybe something to Google later. So next slide. So the ISS is a real complicated piece of equipment. It was built over many years with many rockets from many different, from the US, from Europe, launched in the South Pacific, launched all over the place. And that's what built this system. It's continually being built and updated all the time. In fact, that's one of the things we're going to talk about with this pass, because as they do activities, if they do a spacewalk, if a supply ship's coming, they turn off the radio system. So we'll talk about that in just a second. But that was the launch of ARIS, which is the amateur radio on the ISS. So this was founded by AMSAT, this organization ARIS, NASA support. If you're in Europe and wanting to do the same kind of activity, you'd use the European Space Agency to help you as well. Next. There are 3 different call signs on the space station. NA1SS, that's who we're going to be talking to today. Actually, the DC youth will be talking to today. RS0ISS, that's the Russian one. And does anybody know the last flag? No, Belgium. That's OR4ISS. So if you were in Europe doing this, you talk to that. If you're in Russia, you talk to RS. And here we're doing the North American station. Next slide. So let's talk a little bit about the equipment that's in use today. That little antenna you see there, which is not too big than a stretched out coat hanger, is the antenna that the astronaut's going to be speaking with us with, and we're going to be talking to them. For us, it's much more of a challenge because we've got to point to it. For them, they're just going to be beaconing out a very broad circle, and you'll see that circle when the pass happens. And then you see at the bottom right, the radio that they use. Not nearly as powerful and complicated as the setup we have today here, because again, they're transmitting at about 50 watts down, 25 watts down to us. So we should be able to hear it pretty easily. And then we just got to make sure we get our signal to them. Next slide. And this is what we've planned in the last few months working. So our radio is a lot more complicated than the one on the ISS. This was donated to the station, to the Pacific Science Center on loan from ICOM. So thank you to them. And then the rest of the system is what's built. It's actually right above us right now. This is an antenna system. It's called a Yagi. This was designed by a professor in Japan. And it's a 2-meter antenna. And that's what we're going to be using. 2-meter wavelength is how we're going to talk to them. And you can see it's pretty heavy and pretty big. Those are concrete blocks. It was lifted up by an electrician on a 65-foot boom. And you can see in this upper right part, we've got a dual axis rotor. One to be able to follow the track in an east-west position, and another to raise the elevation so we can tap to today at about 40 degrees. Next slide. Now, let's talk about some numbers here. The ISS today is 268 miles above Earth, and it's moving at 17,121 miles an hour. That's basically the distance from Seattle to Bend, Oregon, and it is, we'll be able to cover that distance in 56 seconds. So we're really trying to catch a ride on a moving bullet. This is really complicated to try and pull this off, but I don't want to make this intimidating for you. When Chloe and I first met and Ryan Weber and N7M came down and we practiced this, we just stood outside with a handheld radio, 5 watts, and an amateur radio handheld antenna, and we were able to talk through the space station. It is not complicated. It can be complicated if you're going to be doing this that we're doing today. Next slide. So this here, as I can look and speak to it, this is our pass today. So when it is directly overhead, you can see that it's going to be slightly north of the Canadian border, and it's going to start rising at 11:13. Now for our rise, it's going to be look right at the Olympic Mountains are going to be in our way. So we're not going to be able to actually see it until it rises above that. And that's when you'll hear Chloe do the call, and we'll hear a call back from Mrs. Epps. So you can see the altitude. It's going to max out at 45 degrees, 10 degrees north. And you can see the distance that the station is. So it's going to go from 2,300 miles away to 581 kilometers away. Sorry. And so we're going to be tracking this thing as it goes. You'll hear the signal change a little bit and be variable. That's just how radio works. Next slide. So today on the space station, there's 5 vehicles connected to it. The Boeing Starliner spacecraft, a SpaceX Dragon Endeavour. That's what the astronauts went up on the most recent pass or the most recent launch. The Soyuz cruise ship, and then 2 resupply ships, one from Northrop Grumman and one from Progress. And the Progress is the Russian system. And there's 12 humans, including the hams that was mentioned by Suzanne. Next. So the current status, if you notice this actually put a bit of fear in us this week, because our pass is at 18:15 UTC, Universal Coordinate Time, but they're gonna turn it off immediately after this pass. So it makes it even more lucky for us. Why? They're bringing more supplies up. So if they do anything outside the spacecraft, they turn off all the amateur radio systems so they don't put that in risk. Now, that to be said, if NASA ever loses communications with the space station because their systems went down, you know what the backup is? Us, amateur radio. So they told us that very early on that we are the backup system for NASA. Next slide. This is their daily schedule of astronauts. Now, when I first saw this, I'm like, how do I show this on a slide and make sense? All you need to know is it's busy up there. They are scheduled down to the minute. They have everything they have to do: exercise, sleep, rest, activity. Everything needs to be put in there. So you can see what all the astronauts have to do. That's why this is so incredibly special for us, to get the time for an astronaut to be able to get on a radio, connect with us, do all the prep work that they had to do with us is not a very easy thing to pull off. But Chloe and the Pacific Science Center, Eris, and all the other hams that helped with this were able to pull this together. So it's really exciting. Next. The value of this 10-minute pass that we're going to have is about $70,000. This is all the professional crew time, the time of the astronaut, all the planning that went into this from Eris volunteers, from the PacSci Center. It is a very expensive thing to pull off, and we are very fortunate that we're of only 2 science centers that got this given to us this spring. Next. So I want to thank all of you for being here. This isn't because of us. It's because of you to have a chance to experience this. I also want to thank Will Marchant. He's the technical director for Eris, and Gordon Scannell, who's hopefully watching right now on the live stream. He was our technical mentor. And of course, the most important ham that we're going to be talking to today, our astronaut. Next. And one last thing I want to mention is ham radio and scouting. Kids are addicted to technology. I'm never going to stop that. But when I take kids out camping, or we take kids out camping, we're going to put a different kind of technology in front of them. We're going to put a radio in front of them. In fact, Jaden, if you raise your hand, Jaden is one of those hams. He went to field day, which is that upper right picture. And after getting inspired about earning the radio merit badge, decided he'd get his license. And what, it took a week? A little bit longer than a week? Okay. Chloe got hers in a week, so it can be done really quick. The center pictures, the hand is my daughter using an Arrow antenna. It is not complicated. This is easy stuff to pull off to be able to talk to satellites. And it's not just the ISS. There's about 50 different amateur radio satellites in space. And I think that's it. So hams have a goofy vernacular. 7-3s is our way of saying thank you, best of luck. And I'll turn it back to Chloe.
Cool. All right. One, thank you so much, Eric, Susanna, and Tim. Those were really awesome presentations. To make sure that we didn't have to cut anybody off of their presentations, we actually added a whole lot of buffer time so that we could hear everything from everybody and get the whole ISS pass. So we do have a couple of minutes, as Nick mentioned, before this pass. So we would like to actually watch an introduction video of Jeanette Epps herself. After we watch this video, we'll give you a couple of instructions of how to engage with the pass itself, because we don't want to disrupt the teens asking the question.
What I love about space exploration is finding out new things, learning new things we never thought we would learn in my lifetime. My name is Jeanette Epps. I am a mission specialist for the NASA SpaceX Crew 8 mission to the International Space Station. I am from Syracuse, New York, where it's very cold. I am one of 7 children. My twin sister, Janet, yes, Janet and Jeanette, we both loved science as kids. Janet went on to become a molecular cell biologist, and I became an aerospace engineer. I think I always secretly wanted to become an astronaut. I just never thought that it was something that was obtainable. In 2008, a friend of mine, Leland Melvin, called me and said that they were accepting applications for the next class. I thought it was my last chance to apply, and so I did. June 2009, I received a phone call from Peggy Whitson, and she asked if I wanted to join the astronaut corps. It was very overwhelming and emotional for me to actually get that call and be selected. Prior to coming to NASA, I worked for Ford Motor Company, and then I went on to work for the Central Intelligence Agency. At both of those places, I learned to be very deep in technical matters, but then also how to become operational. Our mission will entail getting on the vehicle, flying to the space station, taking care of the International Space Station, and then we'll also conduct experiments. Each individual will be an experiment in and of themselves, how our cells behave, how our blood changes, how our bone density changes, muscle mass. We're looking at everything to figure out countermeasures for the human body so that it can live longer and longer outside the Earth's protection. Not only will we be an experiment, but we'll have other experiments on board that we'll conduct. The experiments that we conduct hopefully will get the human body and other things to the moon and then from the moon to Mars. I will be the GEM specialist, which is the Japanese experiment module. I may get a chance to operate their robotic arm to help them with experiments that they'll do outside of the space station. Since this will be my first trip to the International Space Station, I'm looking forward to viewing the Earth from an amazing vantage point, but also experiencing all the nuances that go along with that. As we walk to the launch pad, as we're strapped into the vehicle, the things that I believe I'll be feeling, unbelief, surrealism, but also joy. And then once we go into orbit, just to see the Earth from that vantage point, and then thinking of ways that we're going to work on the space station that's going to help our home that we're now untethered to. When I get to the space station, I'm expecting that it will be like home. We've trained so much here on Earth in the mock-up that looks just like the International Space Station. The biggest thing I'll have to do is adapt to space during the first 2 weeks of being there, and then I'll settle into home.
All right, so that was Jeanette Epps. And I don't know about any of you, but that really inspired me, honestly, and it made me appreciate our time talking with her that much more. Before we get started, a couple of those instructions. When we are trying to initially make contact with Jeanette, I'll be calling out NA1SS to let the space station know that we are ready for our scheduled contact. When we hear Jeanette respond and confirm our call sign, we ask that you do not cheer or clap in any way because it could take up a little bit of the time. That sound would be going into the microphone. And for now, we just want to focus on getting these DC teens able to ask their questions in the mic. After the whole conversation, after about 10 minutes, we're going to thank Jeanette for her time. That is when you can clap and cheer if you were interested. Now, before we get started, we also would like to talk a little bit about what is on the screen here, because if you're not into amateur radio, it can be very confusing. And if you are, or maybe you haven't done satellite communications, it can still be confusing. So first, on the sides, we've got all the logos of the companies and people that have made this event possible today. So we'd like to thank PacSci, first of all, for hosting it, to all the people here who said yes to me doing this, Boeing, Best Buy, Aris itself, Icon for donating radio, and of course, West Seattle Amateur Radio Club for so much of their time that they have spent here on campus and trying to figure out problems at their own homes as well. At the very top, you can see the antenna that Eric discussed a little bit about and showed that is currently on the roof right above us. So we assembled that here. Thank you to Exhibits for allowing us to do that in your wood shop. We had it brought up on that boom lift, and we're going to be watching it track the ISS. Below that, we have the orbit path that the ISS is following. So again, as Eric mentioned, it's traveling at a certain speed. It's crossing over different regions throughout the day. That's how it comes over the same area about 90 minutes. So we'll watch that. To the left of that is supposed to be the camera on the ISS passing over Earth. It may or may not become live. Sometimes it's on, sometimes it's not. But we're just having whatever the ISS provides us. Below that is going to be the radio. So we've got some cables hooked up to the radio there. We are not showing the actual frequencies that we'll be using, but this is showing some of the signals. So we can detect, like you'll be able to see these lines jump up, you'll be able to see the wave come down to show that everything's working properly. So hopefully it stays that way. We have a time, Nick? Okay, perfect. We have a couple minutes then. That's fast, yeah. I'd also just like to give you a quick heads up about what you can expect after the contact. So you might see these chairs behind me. We're actually going to have a Q&A panel. It's going to have our speakers, Tim, Susanna, and Eric. It's also going to have a couple of other people. So we're going to have Nick here, who's currently operating the radio, Vice President of West Seattle Amateur Radio Club. We're going to have Jaden, who is that young teen that got his license with the Radio Merit Badge. And we're also going to have Shane from ICOM, who's the technical expert here, who hopefully nothing goes wrong with the radio, but if something goes wrong, he'd be the best person to ask questions if you're interested in ICOM equipment in general. So we'll just take a few minutes if you want to process it all, and then we'll get started. Yes. That is a really great question. I don't know, but Eric does.
Was the previous pass. And those things are available. If you just go to NASA's website, you can always track the ISS. Or if you're so inclined after the call, don't do it right now. There's an ISS detector app that you can use. And the ISS is very visible in the evenings, usually between sundown and a couple hours after. If it's tracking overhead, you'll see a reflection and it's crystal clear. You'll see it. The scope and waterfall, the bottom part, this is basically, you're seeing right now the background static of just radio waves. That's what it sounds like. That's just normal static. Now you don't hear that on your radios because it's squelched out. That's what Nick just turned on. But you'll start seeing, this is just for the receive audio, right? This is the receive. You'll start seeing it bounce up when the astronaut talks. So I only talk through the space station. So there's a repeater on there. I've never talked to an astronaut. So they'll turn the repeater off. The astronaut will be on to talk to us. And you won't hear the static. It'll be transmit up and then she'll talk down. Hopefully a clearer signal than we have. But if there's a static, we just kind of listen through it. So one of the first things you're going to see, and this is why we put a camera on the roof, was you'll start to see the antenna wake up. So this device that we have, a sat tracker, actually is a mini computer that is telling Nick all this information. And it will basically help make sure the pass is tracked by our rotors. And it actually controls the radio too. Now we're not doing that today because Eris wants us to actually have repeaters, have frequencies set. So we've got all of our frequencies set. And, but this will normally do all the controls. So you put any satellite in and it'll track it. Yeah. Great question. It's FM. Same thing you have in your car. Out of curiosity, how much time do we have? How many of you have used a radio today? Put your hand up if you have not used a radio today. You all are wrong. Anybody use a map to get here? A GPS map? Guess where GPS satellites are? Anybody use a cell phone? Used a radio. Anybody use your cell phone to pay for anything? That's another radio. Anybody use Wi-Fi in your phone? That's another radio. You don't realize how many radios are around you. What's really cool about radio, people have never invented a radio. These are natural phenomena. We just learn how to use them. And so it's super cool. And as my good friend Ryan would always say, it's 1,000 hobbies inside of one hobby. There's so many different places to go with this and so many different things to do. And it's really hard to get us to shut up talking about it. So any questions we can ask about this or what you're going to hear? Yes. The waterfall. I don't know the difference between those two.
Yeah. So the thing that you're seeing in yellow is the current signal that we're receiving. The thing that's falling down, the blue part, is sort of the history. So as the yellow part will spike up, we'll see a bunch of white show up in the waterfall, and it'll slowly fall down the screen. So we would say that the top part is in the frequency domain, and the bottom part is in the time domain and the frequency domain, and is showing us sort of what we heard just a moment before. So we're at 1 minute and 36 seconds.
So the top one is the windshield, the bottom one's the rear view mirror. So there goes the satellite antenna trackers. They're moving into position. And I am going to stop talking now, and we're going to let Chloe, who's going to call the space station, listen and communicate with Nick about when and how she's going to start talking.
All right, PC teams, do you want to come on up?
So I'm going to turn the squelch off, and we're going to hear a bunch of static, but once we start.
As Eric mentioned, at the start of the pass, it'll be hitting the Olympics. So if we don't hear anything, it might be okay. It still might not, but it might be. Good? All right. November Alpha 1 Sierra Sierra. This is Whiskey 7 Alpha Whiskey for our scheduled contact.
Whiskey 7 Alpha Whiskey. This is NA1SS. How do you read?
All clear. We're ready to ask you some questions.
Awesome. I first want to say hi to McKenna Moffett from Mike Barrett, and I'm ready for questions.
This is Hadley. Did you always have the goal of being on the ISS? Over.
Hello, Hadley. I did not always have the goal of being on ISS. My big goal was to be a scientist and to work all over the world doing science, whatever it was. And then the idea of doing science in space also inspired me to go further in science. And that's one of the reasons I applied to the astronaut course. Over.
Hi, I'm Michaela. What inspired you to become an astronaut? Over.
Hello, Michaela. Well, several things inspired me. First of all, my love for science. Ever since I was 15 and working in various places, even at 16 working in labs, always just furthering my knowledge in science. But the more I knew, the less I knew that I knew. I needed to know more. And so as I progressed in my jobs, I worked at Ford Motor Company and for the government, and doing science there just led me to want to do things in space as well. And that would just further my knowledge. And so really it's curiosity that kept me going. But I had several family members and friends that also inspired me to go on further and to apply to the astronaut corps. Over.
Hi, this is Andrew. What kind of training do you have to have before going into space? Over.
Well, Andrew, when you're selected to become an astronaut, most civilians like me, we have never flown jets and different things like that in as a team. And so a lot of the training that we do when we first come on board is we learn to fly the T-38 jet, we learn how to do robotics, we learn how to do a spacewalk, we learn about the space station, we even do analog missions. And analog missions meaning you could live underwater in a small habitat underwater, you can live in a cave, or you can live in other analog missions that will kind of simulate space. So in And then we do, on top of all of that, we do a lot of emergency training. Just in case something happens in space, we want to have the knowledge of how to behave if there's a fire, a rapid depressurization, or we have a toxic leak up here. So we do a ton of training before we actually fly. Over.
This is Celeste asking for Brent. How do you deal with emergencies or unexpected situations when you're in space? Over.
That's a great question. I kind of answered it earlier. We do a lot of emergency training. If we have a fire on board, we do a ton of training depending on where the fire is located. For a rapid depressurization, we go through a lot of training on what to do depending on which module the leak would be in. And so we train to know how to behave in these situations just so that when the event happens, we don't have to think about it. You just automatically go and do what we were trained to do. Over.
This is Celeste again. What is the coolest thing you've ever seen while you're in space? Over.
Hi again, Celeste. Well, one of the coolest things I've ever seen was an eclipse while in space. And what you see from the space station is a shadow moving across the face of the Earth. It's the black shadow that you've ever seen. So it's a little creepy and scary, but it's also extremely beautiful to see. Over.
Hi, this is Rue asking for Derek. How does an astronaut train for life in zero gravity? Over.
A lot of the training that we do is to train how we would live on not necessarily zero gravity, but we do some training for zero gravity, like spacewalk training. We do that at the Neutral Buoyancy Lab, where we're immersed in water and you can become neutrally buoyant, which simulates microgravity. So we do a couple of things to simulate zero gravity, but most of our training that's done underwater is the only training that we really do for zero gravity. Over.
Hi, this is Miley asking for Isaiah. What precaution does an astronaut need to take to safely adjust to life in space? Over.
So Isaiah, the precautions that we take is that we train and we train hard to understand the space station itself, some of the tasks that we'll have to do so that it's almost like muscle memory to a certain extent, so that when we do arrive, everything is very familiar. So that's one of the ways that you can safely adjust to life in space, because it's a familiar environment at that point. And then, every day you're working on orbit, you work safely, understand the procedures that you're operating in, and you talk with the ground, you talk with other astronauts as well. So when we arrive, we are surprised at life on Earth, but it still is a very familiar home for us. So learn as much as you can. Over.
This is Hadley again asking for Jackie. How do astronauts minimize the weight of necessities when traveling up to the ISS? Over.
Hello, Hadley, asking for Jackie. Well, when we launch, we don't take much with us, because what ends up happening is a lot of the stuff that we need is already here on the space station. We have logistic vehicles like the SpaceX Dragon and the Northrop Grumman Cygnus that bring up a lot of equipment that we need, including food, including clothing. And just recently, a couple of weeks ago, we had the Patrick with the robotic arm. It contained a lot of the food that the next crew will eat when they come on board. Our food was already in, so now we're just feeding stuff for the next crews that are be on board in the next half of the year. So we don't really have to minimize the weight of necessities at all. Most of what we need is already here. Over.
Hi, this is Andrew again, asking for Kendra. What personal items are you allowed to take to the ISS? Over.
Hello, Andrew asking for Kendra. Okay, so personal items. I have a lot of personal items for friends and family. Like I have pictures. I have a picture of my mom. I have a Bible that belonged to her. I also have a necklace and a couple of charms as well. I also have tiny stuffed animals for my nieces as well, and things like that for people that I've brought up. I take pictures of them in the cupola and I send them back, bring it back down with me, and give them the picture in the cupola and the toy back. So we can take some interesting things You do have to be careful what you bring, but most things, we don't bring anything too expensive that, if something happens, they don't get it back. So we make sure it's something that will increase in value once we bring it back for that person, personal value. Over.
This is Celeste asking for Olive. What do astronauts do in their free time while up in space? Over.
Hello again, Celeste. Well, there's quite a few things we can do. First of all, one of the favorite things is to take pictures out the windows. There's some beautiful views of the Earth at daytime, but at nighttime, you can see the constellation. You can see the Milky Way galaxy. You can see the atmosphere around the Earth, and nighttime is more active and more beautiful to me than daytime, but they're both exquisitely beautiful. We can watch movies, we can read lots of books. I like to listen to audio books, and we can talk to family. So we don't have a lot of free time. Nowadays we have a little bit more, but in general we're mostly busy. And we do have a little free time, and most of the time I spend it talking with family. Over.
This is Naomi asking for Rue. What steps do you have to take before becoming an astronaut? Over.
Naomi, there's no real recipe for becoming an astronaut. So what I always suggest is that, there's a time when the call for our astronauts go out, know what's on it, know what the requirements are, look at the backgrounds of other people who gotten into the astronaut corps. But even then, there's no real recipe. So I always recommend that you make your life exactly what you want it to be. I wanted to become a scientist, and I wanted to be.
All right, it looks like we're losing the signal, so can we all say thank you, Jeanette Epps? Thank you. W7AW signing off. It worked! Yay! All right. DC, you did such a great job. Thank you so much. It's not over yet, though. We have a Q&A panel. So can we have all of our speakers on that Q&A panel come on up? We've got some seats for you. If you need a few minutes to think of your questions, feel free to do so.
Okay, a little bit of honesty real quick. I had no idea if that was going to work or not. You can't test it out. We could track the space station, we could talk to the repeater, but there was no way to talk to an astronaut first. I thought either this was going to work really cool and these DC youth would have a great time, or you'd spend 10 minutes looking at me and I'd have my 10 minutes of shame forever burned in the internet.
Spot the station.
Say again?
There's a program online that you can use called Spot the Station. If you go to Spot the Station, you can have it tell you when the space station is going to be coming over in a time that you'll be able to see it. So it'll notify you, I don't know, some period of time ahead of time that you will be able to go outside and actually watch it go over.
So how do we do this? Questions?
Sorry. So. All right, first you might notice all of these folks' names on the screen here. So all of them have different backgrounds and different things. So if you have a specific question, one of them will probably be able to answer than all of them or some of them. So you don't have all 6 of them answering the same question. So here's a little bit about their backgrounds if you want to get an idea of what questions you might have answered, and then they'll just kind of pick between them who they think is the best to answer that question.
That's exactly right. It's a Doppler shift. Does everybody know what Doppler shift is? Have you ever heard actually with the emergency group, you guys should probably speak more about sirens, how you hear them.
Well, yeah. So if you hear the siren go by, it sounds higher first and then it sounds lower as it goes by. Where I hear that the most in my radio volunteering is when I'm helping at motorcycle races for safety communications. You hear a lot of that Doppler shift. But Eric, talk about how that works with radio waves.
It's the exact same thing. It's the compression of a wave up front and then the degradation of a signal afterwards. So what you didn't see, Nick, can you explain what you did?
Yeah, so I had a bunch of different frequencies programmed in the radio to account for exactly that. And I was switching through them, trying to hunt for the best signal possible. It was actually pretty interesting because I had to do it at different rates because the space station is traveling relative to us at different rates. So that Doppler shift is not a constant thing. I can't just switch through it one and then wait, a couple minutes and then the other wait a couple minutes. I did very few changes at the beginning of the cycle. And then when it was overhead, I had to switch through very rapidly to hit that signal. And I used the scope. There's a scope on the radio itself to make sure that we were always roughly centered on the signal as we were receiving it.
That's why it got staticky intermittently in the middle. You heard that we could hear her very clearly, and then it would get kind of staticky, and we'd think, oh no, what's happening? And then it would get clear again. That was as he was compensating for the Doppler shift.
Yeah.
Yep. So the question was, when we have things like that Go kit in the briefcase out in the field, we've got a limited amount of power. And what do we do about that? And how do we resupply that? So there are several different answers, but that's a really good question because if we don't have power, radios don't do much. We tend to, a lot of the folks who are Seattle ACS members have a store of a number of different batteries, and some of us have pretty big deep cycle batteries. They look like car batteries, and they will power these radios for quite a long time. So when everything's working fine, we keep those topped up and we have a good charge on them. And in an extended power outage, there are a couple of options. A lot of us have solar installations. And if you have a couple of decent sized solar panels, they will give you power even when it's not a bright sunny day. In Seattle, in the dead of winter, we're not going to get a ton out of those solar panels, but that is one of the options that we have. Some of the locations where we have our equipment permanently installed, I remember I mentioned that we have some installations around the city. Several of those have backup emergency generators that have a good fuel supply, and some of them have provisions for resupply of that. So depending on whether it's individuals stuff or stuff that's part of the more permanent infrastructure, there are various answers to that question. But we have a lot of battery, and then we have off-grid means of re-topping up those batteries or running the equipment right off of it. Eric mentioned an event called Field Day. That's an annual event where we take our gear out into the field, off the grid. We do it around here at South Seattle College, and everybody is welcome to come to that. It's the fourth weekend in June, I think, every year, maybe third weekend. And this year we ran it entirely off of solar power. So meaning solar during the day was just keeping all the batteries topped up. We had a lot of batteries there. And then at night, those batteries had enough charge in them to carry us through the night, making contacts all over the country and sometimes out of the country. So Field Day is a really cool event for anybody to come to. You can drop by. So next June, I hope to see you all at Field Day over at South Seattle College.
So real quick, just to explain what it's like, I want Jaden to talk about it because that's where you got your radio merit badge and got excited by this stuff. Yeah.
So at Field Day, they have like a bunch of tents set up. They have a bunch of stations where you can go learn about different things. They have one of the really cool stations where you could actually go onto the air, even if you're unlicensed, if someone was licensed. I think it's a general license, is that right?
Yeah.
So they would monitor you, and you go on you'd use the radio, and you go you'd use the ACS call sign, I think. So you use the ACS call sign, and you would make contacts with other people doing Field Day in different states all across the country. It's pretty cool. And then they also had another cool thing was you could try out this thing called WinLink, where if you have a computer and you have a radio and you have some special equipment, you can install some software on your computer, and it'll let you send emails through the radio.
Yeah. That's a great question. Yeah, the question was, you talked about practicing with repeaters. Can anybody use the repeater at any time? So the repeater was turned off, obviously, when we were talking with Ms. Epps, but everything's turned off now because they're resupplying the station. But generally speaking, you can go on the ARISS status page, see if it's turned on. If it's on, any of you can listen to it. In fact, you have your handheld with you? Oh, it's okay. Just to show a handheld, surprised we don't have 6 of them on our belts all the time. Just a little radio, this little ICOM radio like this, you can hear the space station. With the antenna that you saw in my slides, thank you. You hook that antenna up, it's more directional, and you can talk to it. So anybody that's licensed can talk to it. The basic license, the very first license, 35 question multiple point choice test with all the questions known ahead of time. So it's really easy. You can just point this thing up, track it the same way we did, and talk to stations that are down on the earth. We did that this morning before you guys came here, so we could test and make sure everything was working.
And with the height up there, 100 miles or whatever it is above the earth, you saw the size of that circle. So that repeater covers a lot of area on the ground. So you here in Seattle could easily talk to somebody as far away as the Midwest, conceivably Alaska, Hawaii. I'm not quite sure. That might be a bit of a stretch, but it covers a huge amount of ground. So it's really cool. You could be here in Seattle and talk to somebody pretty far away, bouncing through the ISS.
Yeah, one interesting thing, we did a lot of practicing through the repeater, of course. And one of the things that sort of gave us a little bit of worry is the first couple minutes of every pass, we weren't hearing anybody, and we thought, oh no, something's wrong, there's a big problem. Well, it's because the International Space Station is passing from the west to the east over us generally. To the west of us is the Pacific Ocean. So there's not very many people in the circle just as the circle starts to pass over us. It's not until it gets farther over us that then we've got, Oregon, Idaho. I think we've spoken to somebody from Arizona, certainly parts all over Canada. So it's pretty exciting, and it's pretty easy to do, actually.
That's a great question. So how does a repeater actually work, and how does it extend that signal out? Basically, there's a receiver and a transmitter it's here and in space. What happens is you transmit on one frequency and it rebroadcasts a different frequency down. So using that ICOM handheld that he has, which has the ability to listen to 2 frequencies at once, you'll be able to hear that downlink frequency. So when I talk up, it comes down to a different frequency. And it can be, normally repeaters are more powerful. So a little 5-watt signal going up, 25 watts coming down, something like that. That's typically how they work. That's how we use them in terrestrial uses like the Seattle ACS. Good question. What frequencies are they operating on? Anybody know the answer? Other than Nick and I? Because we've been doing this a lot. Go ahead.
Yeah, so the downlink frequency for the ISS repeater is 437.8 megahertz. And the uplink frequency is 145. Oh, I can see you know what it is.
900 or 800?
Yeah, 145, 800, 145, 990. Yeah, 145, 990. That's right. And you have to, the Doppler shift affects that, right? So you actually have, what we did here was we programmed, we had 7 memory slots that programmed from a +2 kilohertz shift, which is, the speed of light, right? And the ISS is traveling so fast that the waves the radio waves are impacted on the order of +3 kilohertz. And then it comes back to exactly those frequencies. And then as it's moving away, we go to -3 kilohertz. So it's crazy fast.
And
90 minutes around the earth.
One thing to add about the past today, there were several scouts that wanted to come to this that are actually at scout camp, and they couldn't be here. So their parents took with them radios so they could listen to the downlink, because today's downlink was 145.800. If there's ever another station, the school contact, you can watch live streams, but if it's close enough, you can actually listen to it on that kind of a radio with a better antenna. How much airtime did the Olympics cost us? That's a really technical question, and I don't know if I know the answer. I bet some member of the Seattle ACS or West Seattle Amateur Radio Club might know that. The question was, how much did the elevation of the Olympics, why the space station was behind it, how much time did that cost us for our contact?
Oh, I mean, so I think Chloe, yeah, it was not very much at all. Yeah, I was totally surprised actually, especially because in our practice runs, we wouldn't actually start to get any inbound signals until 2 or 3 minutes into the pass. In this case, I think Chloe, you did one call and got nothing, and then the second call she came. Yeah, so it was almost immediate. That was very impressive.
Yeah, the Olympics are only what, maybe a degree or something from here. So we lost maybe 1 degree from the pass.
Yeah, they move very fast. Yeah. Any other questions? Okay.
Yeah, we saw this actually. It's a great question, and we sort of talked about it before, but the peak on the waterfall kept shifting because that was when I was switching to a different memory channel. And so what would happen is that the peak on the waterfall would slowly and very smoothly shift. That's the Doppler shift as it's changing, right? As it's changing from +3 kilohertz to 2.5 kilohertz to 2 kilohertz. And then I was then switching 1 kilohertz steps because that's how I had the memories programmed. I could have done it much smoother, right? I mean, it would have been possible for me to really finely tune in 1 hertz increments, but that would have been a really fine control. So we had 7 channels basically set up that we were switching through. And so when you saw it jump all of a sudden, that was when I was switching it to the next Doppler shift that was programmed.
I'd like Shane maybe to answer just kind of this radio has immense capacity and it's fine tuning. We could have kept a crystal clear signal the whole way through. Eris doesn't want us to do that because if anything messes up, the memory channels are a foolproof way to do that. But you want to speak to the power of that radio?
Yeah, so that radio has a satellite operation mode. So you can use the BFO knob and shift the frequencies as the Doppler shifts happen. And that radio has a RF power output of 100 watts. So it's a very powerful radio that we can use to talk to the satellites.
Yeah, it was, there was a point at which we had an issue receiving the signal from the repeater. And so Chloe was transmitting out the call sign saying, hey, we can't hear the downlink. If anybody can hear us, can you please email us via the email on our QRZ page. QRZ is sort of the social network for hams. And we got like 4 or 5 emails from different people all over the country saying, yes, I heard you and you were booming. You guys need to turn down the power because you're totally drowning out everyone else. So for today's contact, we used 100 watts, which is a lot of power. When we were practicing with the repeater, we were actually reduced the power to make sure that other people could, they could use the repeater as well. Because it's a shared resource, right? And that's sort of part of the beauty of amateur radio.
Yeah, you saw that photo of Eric's daughter with a little handheld radio talking on a satellite with a little handheld radio. Those typically put out 5 watts. So if you think about it, the lighting in this room is orders of magnitude more electrical power than it takes to talk off of a satellite.
Yeah. I think that's a question for the Pacific Science Center.
Thanks for asking. We're super curious about what we can do with this. PacSci loves curiosity. So we do have the station on loan, but it's not just ending after this event. We currently have it on loan for up to a year, and that could be extended. So we're thinking of different ways this could be turned into a permanent station, but that takes a lot of engagement from everybody here and also donations. Sorry. So we're thinking of maybe turning it into an exhibit to go with some of our space exhibits where you could tune through all the different satellites and just hear people talking through those repeaters. It could be something that we keep involved with our Tinker Tank department, which I'm part of, which is a lot of hands-on activities. So that's how the DC teens were able to do a lot of hands-on activities because we hosted them. So one, we would love to hear your ideas, and two, we would love to hear how you think that idea could be a possibility and actually turn into something into fruition. Yes.
Can you talk to folks that don't know a little bit about what?
Absolutely, yeah. So these DC teens here, they're a department here led by Minuet and Chin Chin. So if you'd like to share about the curriculum you went through, definitely feel free to do it. So they kind of split it up into two sections. So Minuet and Chin Chin, they led the curriculum in the DC office, taught them all these lessons about just the introduction to amateur radio. None of them have had their license. None of them had heard of it before. So they learned the very basic components, and then they came into our Tinker Tank shop and we provided all the supplies for them. We taught them how to solder, use all these different materials. So thank you to my team for helping out with all those workshops. And then that has been happening through the last 6 months. They finally finished their fox hunt. They finished all their lessons. And this was like the end of that big curriculum unit. A fox hunt is interesting and a lot more difficult than it seems. So you can do this with any antenna. I myself and the DC teens did this with a tape measure antenna. So we just got a tape measure, some PVC pipe, and some very simple coax cable and wire. You cut different lengths of this tape measure, you attach it to the PVC, and then you solder some, again, very basic wire to it. Then if you have an attenuator kit that you make yourself or you can buy, you can adjust it as your direction finding. So we had a member of our education department go hide in Seattle Center. None of us knew where she was. And the teens had to go take their antenna and their attenuator kit, as well as a handheld radio, to pick up the signal that the transmitter that she was holding was sending. So they would direction find. If they got too close, sometimes that would become a problem and the signal would just cut off and they'd be like, I lost her, I'm so far away, but really they were too close. So that's when the attenuator comes in. You just have to adjust a lot, as Nick mentioned with the frequencies. It's a whole lot of adjusting and thinking you're doing things wrong. And then once you can see line of sight, they saw the person that they knew. They're like, oh, that must be the person with the transmitter. So that's completing the fox hunt. But Eric's done this with scouts a lot of times in the woods. You can send them off of a path. We did it when I did it with Ryan and Eric. We also did it near Seattle Center out the back. So you can do it anywhere. Yes. Yes, exactly. That's a great analogy. Thank you. So it's like hide and seek or Marco Polo.
Oh, great question. What's the youngest you can be to be a ham radio? You have to be a human being. If you can pass the test, you can you get your license. So there's literally no limit.
Yeah, So we started, Jaden was a big part of this, doing a youth on the air net. It was on Thursday night nets using the Seattle ACS repeater, just trying to get young voices on the air. There's enough gray hair in this hobby. We wanted to get people that look and think more like Jaden does and bring some more interest to the hobby. So one night we had a 5-year-old girl get on. Her dad got on with the 5-year-old girl and she popped her name out there and gave me her call sign. I almost couldn't believe it. Yeah. If you wanted to get an amateur radio, what's a minimum equipment required? And there's a lot of ways to answer that question. Most people start with a handheld radio. There are brands that are really cheap and don't have a lot of features to them. They're still fully functional. You can get them for $25, and you could get a top of the end one like this Icon one that does digital modes and all sorts of stuff that is a little bit more expensive, but it doesn't cost much. And you can get used equipment. And for anybody that's a youth, we've been giving them a free radio. So we just want to get the West Seattle Amateur Radio Club donates one of these small radios just to get people on the air. If they pass their license. we do training. If you go to the w7aw.org, you'll see classes. You can teach it on YouTube lessons. Chloe started studying and you told me, I think you lied to me, but you said you don't have a science background. You're not a STEM type person. And you started studying and passed it how many days later? Like 6 days later. So she comes and says, hey, I passed my test. We're like, you're kidding. She had to wait longer for the FCC to give her a license than it took to actually pass the test.
But we also, there's lots and lots and lots of events, like the first Monday of every month at the Center for Active Living in West Seattle. We have what's called the Ham Jam. That is Jim still here in the, yep. Jim runs that. And so he's there willing to help people, you know, figure out how to program their radios or even just get them on the air. Oh, yes, the club picnic. That's right. Well, W7AW will be in Alki. Yep, the only one on the beach. And we'll be there. We'll be operating radio. We'll have a bunch of stuff. So that's a great way to talk to people. In fact, I've been having an email exchange with someone who said that she got a ham radio in the divorce and she wanted to know how to use it. And so I said, well, come on down and we'll show you how to use it. So yeah, yeah. That's
Where's
right.
the first Saturday breakfast? Where?
The first Great American Diner, first Saturday of every month at 8 a.m. when it opens. So.
And then the second Saturday of the month is when Seattle ACS has its meetings. Those are open to the public. So if you're curious about it, get in touch with one of us through seattleacs.org or come talk to me afterwards. Those are at North Seattle College. So you can drop by and see what we do. Question over there.
Yeah, so just for folks on the stream who might not have heard Alan, another one of our important club members, we have classes that we're actually teaching through the West Seattle Amateur Radio Club, free classes to attend over Zoom. If you go to w7aw.org, you can find more information about that. And then we'll be, as Alan was pointing out, we'll be running in-person testing. There's lots of online testing too, if you're not into in-person stuff. So. Yeah, LakeWashingtonHamClub.org, for instance, but there's many, many, many options for doing that.
We have just a couple minutes left. Anything else?
Let's see.
My wife is in the stands. Don't say it.
Yeah, I think I've got 4 handheld radios and I've got 3 or 4 different mobile radios and I've got a really nice ICOM 7300 for my HF station. So yeah, I've only been a ham for a year.
A lot of hams suffer from a condition called GAS, which is gear acquisition syndrome. It's a serious condition and sometimes never treated through life, but you know, you can take this as far or as little as you want to. But yeah, it's a lot. There turns out to be, whoever it was that said it's 1,000 hobbies in one. That's really true. We haven't begun to scratch the surface of all the different things people do with this for fun and for public service. So it can literally, you can do a lot with just one handheld radio.
But it's like bicycles. How many do you need? One more than you currently have.
Yeah. Yep. And you can borrow them. Hams are some of the most remarkably friendly people. We loan stuff. I have stuff I probably don't even know I've given out, you know, but my favorite radio is the one I have in my truck. My wife was driving back from Pullman yesterday and said, don't call me. The winds are really bad. I just had a car had a blowout of a tire beside me. And I was able to just track her progress and see that she was still making progress across the state because the radio was beaconing out her location to the internet, and I could track her coming home that way. So it's some really cool, fun stuff.
I have about 4 working handhelds right now. I have one that broke when I was at camp. Someone stepped on it and the screen broke. But in terms of like actual working handhelds, I have 2 DMR handhelds, and I have it's a digital mode. So instead of having like analog where it's like FM radio, you can tune into it. You have digital where you just get the raw, or instead of having raw audio, you get like a encoded signal, kind of like you would through a computer. I have 2 analog handhelds that are they work, and that's that. Then I have like a bunch of FRS radios, which are like kind of like the ones you buy at Walmart.
I have a lot that I lost count actually. I think I have more than 10 handhelds and probably close to 10 mobiles and maybe 5 base stations. I just got too much.
Yeah. Kurt, if you're in West Seattle, you'd see a ton of radios, a ton of aluminum. And when Kurt had to re-roof his house, and so we had the fun opportunity to bring it down, and we'll have the fun opportunity to put it back up. Yes.
For folks on the stream, we actually have friends of Michael Barrett, who's on the ISS right now in the audience. So we have astronaut adjacent folks right here live. I want to call out and give Chloe a big shout out because she believed in this before anybody else, and we could not have done it without her constant support and like her vision for this whole thing. So great work.
Yeah. Nick stole my thunder. Chloe doesn't like being put on the spot, but I put her on the spot. This was her idea, her application. She did everything, coordinated the volunteers, got all the background checks done, did all the contracting. So yeah, thank you, Chloe. This was awesome.
Yeah, this all starts with an education focus. That's what this whole thing's done. When Chloe first contacted us, I didn't believe she was going to pull this off, but it was her vision that did all this. I was just happy to go along for the ride. I think Nick would be saying the same thing, but this was a lot of fun, a lot of hard work. I can't believe it actually worked, but I know Chloe has a big smile on her face and she's going to look forward to taking a couple of days not thinking about radios, I'm sure. Once we've done it once, if you have a school that's interested in this, if you're a student anywhere, if you're on a live stream and a part of a science center or something like that, I think one of the goals of this is to help you do this. Nick and I learned a lot that we didn't know beforehand. That wasn't information given to us. So we're going to write all this down. We're going to make it available on the West Seattle Amateur Radio Club website so that other schools, anybody else who wants to do that will be able to learn how to pull this stuff off, but especially led by what Chloe did, which was tremendous.